welcome back. Today we're going to be talking about programming design. So it's going to be something I think a lot of you guys really enjoy. Alright, with this, behavior-based programming. A behavior is anything that your robot does. Turning on a single motor or servo is a behavior. Three main types of behaviors. You have complex, simple, and basic behaviors. Everything that we're going to be doing is a basic behavior. We want to take complex behaviors and turn them into several lots of basic behaviors, because it's lots of basic behaviors that make up a complex behavior. For example, throwing a baseball is a complex behavior. Simple behaviors: grip the baseball, pull your arm back, extend your arm, pull your arm forward, bending your elbow. Alright, as you come forward, step. All of those are simple behaviors, but every single one of those steps I was talking about, as we put those together, once you put them all together and actually throw the baseball, that becomes a complex behavior. So when we're creating pseudocode, we want to break down your behaviors into individual actions. We're going to break them down into simple behaviors is what we're going to be doing. And again, I want to re-emphasize, break the complex behaviors into simple behaviors. That's going to be really hard for you guys when we start off. Alright? List these behaviors line by line. And then describe actions and what prompts each action to continue. Alright? When you tell a computer to turn a motor on, it's going to keep running that motor until you tell it to turn off. So we need to make sure that we know how to tell it to turn off or when to turn off. Okay, pseudocode. Pseudocode is when we are creating, we're putting down in our own language what we want to happen. We want a warning light to come on before the fan starts for 3 seconds. So we want that warning light to come on for 3 seconds and then the fan starts. So that's pseudocode. Alright, it's not really coding, but it's telling us what we want to have happen. The fan turns on and runs until a button is pressed. That's pseudocode. We're telling us what we're going to program. A different light comes on for 3 seconds before the program stops. So what we've got here is we've got three simple behaviors. When you put this all together, it would be a complex behavior. Okay, when you think of your basic behaviors, think of what your input devices and your output devices have to do. Alright? It helps you if you can think in terms of each input and output component will be on your device. So what we're talking about here, warning light comes on before the fan starts for 3 seconds. Here we've got to break this down. So here's where we were. This is what we're getting closer to here now. Alright, program begins. Light 1, what is light 1? Well, we've named it LED because the computer doesn't know what light 1 is. Alright, it only knows what an LED 1 turns on for 3 seconds. Then we tell the computer the fan, which is motor 1, turns on until a button, which is the bumper switch. So here we're telling it this is our output device. The light turns on for once, that's our output. Again, here's our next output, the motor 1, until what? An input. We put something into the computer. Something puts information in the computer. In this case, it's a bumper switch. Alright, again, light 2, that's an output. Lights are outputs, motors are outputs, servos are outputs. Turns on for 3 seconds. Alright, program ends. From this point on, I would advise you to go ahead and open up Robot C at this point and do these things along with us here. Alright? Open sample program PLTW template. Use the initial description, complex behaviors, or your overall program goal as the task description. Copy pseudocode basic behaviors for the pseudocode section of the PLTW Robot C program template. So what we're saying here is we got these different categories. Task description. Alright. A fan will run until someone needs it to stop. There will be a warning light as a safety device before the fan turns on, and another light to indicate that the fan has stopped. So this is how we would talk about it. Alright, this is how we would talk about it. Pseudocode down here. This is complex behavior. Pseudocode is when we start breaking it up into its simple behaviors. Alright, its basic behaviors. Alright, the program begins. Alright, light 1, LED turns on. So after that, it's going to run for 3 seconds. The fan motor turns on until a button which is the bumper switch, is pressed. Light 2, which is LED 2, turns on for 3 seconds, program ends. Now that'd be nice if that's all really the farther we had to go with this, but now we've got to actually create some task, some code. Some things I want to point out to you guys. This is important. Okay, there's a reason why all of this stuff up here on top doesn't get put into the program. And the reason is because up here they're starting it with a backslash and a star, and then they have a star and a backslash, which means everything from the backslash star to this star and backslash, the computer forgets about. It doesn't do anything with. This is all for your benefit. So the up here with the title, the team members, the date, the section, the task description, the pseudocode, the computer doesn't do anything with this. This is just gibberish to it. What the computer cares about is what we're putting in between the parentheses. So down here where it says task main, make sure you start, and it's really not a parentheses, it's a bracket. You've got to have a bracket at the beginning and a bracket at the end. All right. Program begins. Light 1 LED turns on for 3 seconds. Fan motor 1 turns on until a bumper press is switched for 3 seconds. So this really isn't going to do anything either for us. What we've done is we've taken this, and the pseudocode is what comes after. Our programming is going to come over here in front of these double backslashes. Okay, as you're doing this, all right, our pseudocode, again, is over here to the right. This is the pseudocode. All right. The program's not going to do anything with this. This is for your benefit. We'll start off by saying the program begins. What we'll type in here then is start motor. Okay, some things I want to point out to you here. Notice we're saying start motor. All right. A lot of these things you can just type in and it's going to finish for you. Things I want you to see here is whenever we do start motor, you're going to tell it which motor. You've got to put the comma, and this means power. How much of the power are you wanting it to use? And then we're going to finish it with a colon. All right, and it's because you're giving it a command. Whenever you write a command, you've got to finish with that colon. For example, here you're saying wait, and then you're going to put the time, and you're telling it to it, you're giving it a command, so you've got to finish it with a colon. Again, stop motor, you're telling it what to do. Stop. All right, and you got to tell it which motor again. All right, you don't have to tell anything about power because the power would be 0. You're going to stop it. Stop motor, and you're going to finish it with the colon. Here they're telling you that same thing. All commands belonging to the task main must be in between the curly brackets. They call them curly braces. I would call them brackets. Here they're saying turns the right port 2, the right motor on at half power. 63 is half. It's actually 127 is full, so that's about half. Same thing here. They're telling you to wait. Notice, but a command has to finish with the colons. I keep saying that. Here they're telling you that, again, that we're going to stop the right motor. All right. You could type in STOP, and you're going to have some choices that are going to pop up there for you. I wish that mine was working right now, and I could show it to you. The end result is the right motor spins for 5 seconds. Right? So all of this is to get the motor to spin for 5 seconds. Okay, what this is saying here is sometimes, a lot of times, most of the time, when you guys write your program, it's not going to work. And we get too caught up in the complex behavior. Instead of looking at, well, let's look at our basic behaviors. Is my first one working? Yes. All right, so let's go to the second thing I wanted to do after that. No. So it's not that the complex behavior is not working, the program's not working. What matters is the second part, the basic behavior is not working, and that's what needs to be fixed. You may find out once you get that one to start working that your third one doesn't work either, but you don't know until you've worked your way through the steps. And there's a process for that we'll show you. Okay, what I want to point out here to you now, what we're talking about here is turn LED on. You're giving it a command, so it's going to have to finish with a colon. Inside, whenever you're turning an LED, all you have to do is tell it which LED. All right. Wait, that's a command. You're telling it this right here is in seconds. All right. Finishes with the colon. Turn LED off. Which LED? Because you might have several LEDs. It's a command, so you're going to have to finish with a colon. Again, I want you to notice that everything, you see the first bracket, what they're not showing you here is that somewhere down here is the other bracket. And it's a left and right bracket. Sometimes students get caught up, they have have a left and a left. But these brackets always have to match up. For every left, there has to be a right. Okay, here, I was just talking about this a little bit ago where I said we have these ways of testing one behavior after another. So we can break it down into simple behaviors and see, is the first simple one working? Yes. Is the second one working? No, and so forth. Well, the way we go about doing that is they're showing us right here. Remember at the beginning where I said that whenever you put something as a backslash star and then a star backslash, what that does is it turns off everything in there to the computer. So even though it's inside the task main, what this means is the computer is ignoring this part. So what has probably happened then is that we've identified that the first part's working and we say something's wrong here. Or we're going to test now just this part. Does this part of the program work? And this allows us to test each simple behavior without going on to the next step. If I wanted to turn this back on, then what I would do is I would get rid of this and get rid of that, delete those, and this will automatically look like it used to. If I wanted to now turn off this part, I would hit backslash star and then star backslash, and that would now turn this section right here off to the computer, and I'd only be running the first part. Well, hey, hopefully that was beneficial. I'll catch you on the flip side.